Welcome to Sundar's lecture. This is lecture number 32, and in this lecture we are going to see realization of other flip-flops using a T flip-flop. So what are the topics we have seen in the previous class? So we have started with the topic conversion of that means realization of other flip-flops using D flip-flop, and we know the steps, right? So first one is the you need excitation table, and then you need truth table of the flip flop whichever you need to convert, and then you need a conversion table, right? So from conversion table what we have seen, you can see here from the conversion table we have just derived the um, expression for D using the Karnaugh map, and from this D expression we have just drawn the logic diagram. So this is how we have converted the other flip flops using D flip flops, right? So we have just made use of the D flip flop, and we have just converted other flip flops operation using D flip flop. So this is the topic we have seen in the previous class, and in today's class we are going to use T flip flops. So that is the next topic we are going to see, and the point is the first one. So realization of other flip flops. So first I will take the topic A, that means first one. So we are just going to convert T flip flop to SR flip flop. That means we are going to use SR flip flop. Sorry, we are going to use T flip flop for SR operation. So the first one, we need the excitation table of the T flip flop. That is the first step. So we have taken that, and then truth table of the SR flip flop. That also we have taken, right? So the next step, we need to derive the expression using that means we need to write the T input. We need to put the T here using the excitation table that we know we have seen in the previous class. So what is the thing? You need to see Qn and then Qn plus 1, and I have already told you this is a present state and this is next state. In other slides I may use a present state and the next state. Please be with me. If it is Qn, then it is a present state, and if it is Qn plus 1, then it is a next state. Anyhow, so if it is 0 0, so if it is 0 0, the output that means the T will have 0, and then 1 1 means it is a toggle, so so it has to become 0, and the next one is 0 0, so no change, it becomes 0, and then from 0 here 1 0, right? So 1 0 it is 1, and then as for 0 1 also it is 1, and then for 1 1 for 1 1 it is 0. So for 1 1 it is 0, and we have seen this one, right? So what is the point in the conversion of SR flip flop? We never give 1 1. So for these two cases we are not going to give that input. So the T input may be anything. I don't care about the T input. So this should be X and then X. So this is how we have derived the T input. And what we need to do the next one, we need to draw the Karnaugh map for S, R and then Qn. The output should be T now, right? Because you have inputs as S, we are going to give S and then R, and then Qn can be taken from the T flip flop. So that is what we have taken here. So if you use these three, that means I have just written the minterms here from 0 to 7. So you just put the values now. It is 0 0 0. So first it is 0, and then 0 for 2 it is 0, and then for 3 it is 1, and then for 3 it is 1, for 4 also it is 1, for 5 it is 0 actually, and for 6 and then 7 it is X, right? So this is how we have got the Karnaugh map, and how you can cover these two ones. There is no quad possibility, so obviously you cannot go for quad possibility, right? So no quad possibility, only you can go for pair, right? Because no four adjacent ones are equal. If this is one, then we can go for quad. Anyhow, so what we can do here, you can make these two as one pair and these two as another pair. So these two as another pair. So pair number 1, so I will write the expression here. So this is a pair number 1 and this is pair number 2. For pair number 1, what should be the expression? the expression for pair number 1 it is RQN, it is RQN, and for pair number 2, what is the expression? You have to take this S as it is, and the you can see the common term, it is QN bar. So what is the T input we are getting here? So I will write here itself. T should be is equal to, so S Q N bar plus R Q N. So this is the T input. For the T we need to give this input with the combination of S and R, right? So that is the idea. That is what we are expecting. So we have just derived the expression. So what is the next step? You have to draw the logic diagram, right? So for drawing the logic diagram, so what is the flip flop you have? You have T flip flop, right? Now you are having T flip flop with you. So this is T, and then this is QN, and this is QN bar. So you have this one with you, right? So what is the input you are having? So what is the two inputs you are having? Both inputs are S and R, right? So S and then R you are having. So the inputs are S and then R, and this is T flip flop. You know this one. So what is the idea? So you need one OR gate. You need one OR gate. That output should be connected to T. That output should be connected to T. So that is the idea. So this should be connected to T, and you have two inputs now. Two inputs. So what is the first one? So it should be SQN bar and then RQN. This is the two inputs you need, right? So you have both inputs. So all the terms are you have here itself. So you need to draw the AND gate. So you need to draw the AND gate. So this is the AND gate. So just you can connect it down. So this should be connected to this end, and this should be connected to this end. So what should be the input now? So one should come from S and the another one should come from QN bar, right? So QN bar is here. So QN bar, and what is this one? One should come from R. So it has came from R, and the other one should come from QN. So it should come from Q. Where is this one? It is here. So it should come from here. So this is the diagram now. So you can directly write this one now. So this is SQN bar plus RQN. So the idea is, what is this one now? So from here to here. So from here to this point, this is nothing but SR flip flop, right? So what we have done now, we have just converted. If you give 0 0, then the output should be what? 0, no change, right? Whatever it may be, the previous state may be 1 or 0. The output should become sorry, no change condition. If the previous state is 0, the present state becomes 0. So the idea is, if you give 0 0 0 1 1 0, this whole thing will work like a SR flip flop. That is the idea. So we have just created the SR flip flop operation using T flip flop, right? The next one, we need to go for operation of D flip flop using T flip flop, right? That is the next one. So I will just put all the diagrams and I will show you. So the next conversion, it is a T flip flop to D flip flop, right? So the first one is, we have just taken the excitation table of the T flip flop and then truth table of the D flip flop. This is the truth table of D flip flop, and for the conversion table, it is very simple, right? Because if it is 0 0, so if it is 0 0, then what should be the content? If it is 0 0, then it should be 0, t should be become 0, and from 0 to 1, sorry, here it is 1 to 0, right? So 1 to 0, so it is 1, and from here it is from 0 to 1, right? So from 0 to 1, again it is 1, and for 1 to 1, so 1 to 1 it is 0. So this should be the uh, t input. So we have just derived the t input with respect to d. Anyhow, so what we need to do now? So we need to draw the Karnaugh map for d and then qn. Since it is a two variable input, so the you can write directly, right? Because if it is 0 0, it is 0, 0 1 it is 1, 1 0 it is 1, so 1 1 it is 0. What is this one now? It is actually the XOR of these two things. So what you can do here, you can directly write t should be is equal to d XOR of qn. Very simple, right? So you don't need to put the Karnaugh map, and it is not necessary to put the Karnaugh map for the t derivation, for the t expression. So it is very simple now. So what you can do now? So the next step, that is E logic diagram, and that is also very simple. So for logic diagram, what you need to do? So you have a t flip flop with you, so that we know already. So this is the t flip flop, right? So t flip flop is with you. So this is qn, and this is qn bar, and this is t input. So this is t qn, this is qn bar, and the inputs you know, right? So you have only one input here. You have only one input. So what is that input now? So it is d input, and what is the expression you have now? So it is a XOR of these two. So directly you can draw the XOR gate. So directly you can draw the XOR gate. Just draw the XOR gate. Put this one. So one input is from D, that we know, and the other input is from, it is connected to this point. So the other input is from simply here. So you can just connect these two. So point is, this is D and this is Qn. So this is actually D XOR of Qn. That's all. So we have just made this one. So the D flip flop can be worked as a, sorry, the T flip flop can be worked as a D flip flop. Now you can see this. So now this is a D flip flop. This is a D flip flop. Very very simply you can draw this one. So these kind of things will be very useful in GATE exams. Maybe they will ask you the relationship between T flip flop and then D flip flop. This is the relationship, and you can directly write these kind of relationships. So it might help you in solving problems in GATE exams or competitive exams, right? So the next topic, we are just going to convert JK flip flop into T flip flop, right? So sorry, T flip flop into JK flip flop, right? That I will show you now. Right. Now you can see the next one is T flip flop to JK flip flop, right? So what we need to do, we need to take the excitation of the T flip flop, truth table of the JK flip flop, and I have taken both things, and you can see here the conversion table. You can see here the conversion table that it is a JK and then Qn plus, and you can directly take the truth table here, and we need to derive the T for this present state and the next state. This is actually present state and the next state. I am repeatedly telling you this Qn, it is present state, and Qn plus 1 is the next state. And what we need to do for 0 0, what is this one? It is 0. So it is 0. For 1 1 also it is 0. For the input change, it will have 1. For no change from the present state to next state, the T input will become 0. So that is the idea. So it will be now 0, this is 1, this is 1, this is 0, this is 1, and then this is also 1. So this is how you will get the T inputs. So what we need to do, anyhow, we will cross check it once again. 0, both are same, 0, both are same, 0. it is a change is 1, it is a change 1, it is the same, no change 0, change. So everything is correct now. So what we need to do, we need to just put it in the Karnaugh map to find the expression for t. So for that we need to take j, k and then qn. That is what I have taken here, and I have also taken the minterms here, so from 0 to 7. So what we need to put here, this is 0, and then 1 is also 0, 2 is also 0, but 3 is 1, and 4 is 1, 5 is 0, right? So 5 is 0, and 6, 7 are 1. So how you can connect these kind of things? It is also very simple now. What is the idea? So you can see here, you can take this as a one pair, this as one pair, and this can be connected to another pair. So what should be the t now? So I will directly write down here, the t should be is equal to, so this one it is a kqn, that is the first pair, and for the second pair, put plus here, the second pair will be j directly, but it is qn bar. So this is how you will get the expression for t. And what we need to do now, we need to just draw the logic diagram using the expression t. So the next step, logic diagram. So how will you draw the logic diagram? So the point is, you are having t flip flop with you, t flip flop, and this is qn bar, and this is the t input. So you know these kind of things, right? So t, this is qn, this is a qn bar, right? So this is t input, sorry, t flip flop, and what is the input you are having with you? This is the first one, that is j, and then you have k, both you have, right? So this is j, and then this is k. And what is the expression you are getting here? You need a OR gate to connect these two. So OR gate output should be connected to. So this will be the OR gate. So OR gate should be connected. So it has two inputs now. The OR gates will have two inputs, and both should be connected from a AND gate, right? So both should be connected. The input should be connected from AND gates. Two AND gates you need. So this is connected here, and this should be connected here anyhow. So this the idea is, this should be jqn bar, and this should be kqn. So how will you connect this one now? From j you need to take one input, so I will just take from here, and from qn bar, so you have to connect one from here, qn bar, so it should come here, and we should connect like this. And what is the next one? This is k, right? So straight away you can put from k, and the next one is qn, right? So it should come from here. So just here. So what is this one now? So actually this is j is connected, and then a qn bar is connected. This is j, and then this is qn bar, this is k, and then this is qn. And what should be this one now? So j qn bar plus k qn. So you have got it down. So the point is, what is this one? From this point to this point. So from here, and you have to connect here. Will you connect this one like this? So what is this one? Simply, what is this one? This is actually JK flip flop. And if you give 0 0 to this one, what will be the output in QN? No change. And if you give 1 1, then it is going to toggle. and if you give 1-0 set, reset, everything will come in JK flip flop. You know the working principle of a JK flip flop. So we have just made a T flip flop into JK flip flop simply, right? So we will wind up today because I need to start a new topic. That means we need to convert a JK flip flop. We have to realize other flip flops using JK flip flop, and we cannot complete it within the time. So we will see that in the next class. So what are the topics we have seen in this class? So see here we have started the topic of realization of other flip flops using T flip flop, right? So for T flip flop, for the first step we need to take the excitation table of the T flip flop, and the second step we need to take the flip flop whichever you need to convert, right? So this is SR flip flop truth table, and we have just drawn the conversion table, the present state and the next state that was taken from the excitation table, and we have derived the T inputs, and now we need to, with the help of S, R and then Qn, we need to derive the expression for T, because you have S and R Qn, right? So with the help of these three, what we have done here, we have just drawn the Karnaugh map to get the expression for T, and we have got T here. So simply we have just drawn the conversion logic diagram, right? So conversion table, and then from conversion table we derive the expression for T and drawn the logic diagram, right? So this is the principle. We have just followed the same principle for all other conversions also: excitation table, truth table, conversion table, and then finally we have just drawn the logic diagram. Same thing, right? And this is for T flip flop to JK flip flop. So this is how you need to connect the JK flip flop, right? So we have just drawn the logic diagram of a JK flip flop using T flip flop. The expressions are very important. These expressions are very important, right? So we will see in the next class. Thank you.